The role of nuclear power in meeting electricity demand. The growing demand for electricity worldwide, driven by rapid urbanization, industrialization, and the increasing use of digital technologies, poses a significant challenge for sustainable energy production. While renewable energy sources like solar, wind, and hydropower are expanding, they alone may not be sufficient to meet global electricity demands reliably and sustainably. This paper argues that nuclear power is essential for meeting future electricity needs and explores the advantages of using sodium-cooled reactors with thorium fuel over traditional uranium-based reactors, with a particular focus on developments in China. The role of nuclear power in meeting electricity demand. Historical context and current status. Nuclear power has been a significant part of the global energy mix since the mid-20th century. The first commercial nuclear power plant began operation in 1954 in Obninsk, Russia. Since then, nuclear power has grown substantially, with over 440 operational reactors worldwide, contributing approximately 10% of the world's electricity as of 2020. Countries like France, the United States, and China have made substantial investments in nuclear technology, recognizing its potential to provide large-scale, low-carbon electricity. Advantages of nuclear power. Low carbon emissions. Nuclear power plants produce minimal greenhouse gas emissions during operation. Compared to fossil fuels, nuclear energy offers a cleaner alternative that can help mitigate climate change. High energy density. Nuclear fuel has a much higher energy density than fossil fuels. A small amount of nuclear fuel can produce a significant amount of electricity, reducing the need for large quantities of fuel and the associated environmental impacts of extraction and transportation. Reliability. Unlike solar and wind power, which are intermittent, nuclear power provides a stable and continuous supply of electricity, essential for meeting baseload energy demands. Sodium-cooled fast reactors, SFRs. Sodium-cooled fast reactors represent an advanced nuclear technology with several benefits over traditional water-cooled reactors. These reactors use liquid sodium as a coolant, which has superior thermal properties compared to water. The advantages of SFRs include higher efficiency. Sodium's higher boiling point allows the reactor to operate at higher temperatures, increasing thermal efficiency. Enhanced safety. Sodium cooling systems can passively remove heat, reducing the risk of overheating and potential meltdown. Waste reduction. Fast reactors can utilize a wider range of nuclear materials, including spent fuel from traditional reactors, thereby reducing nuclear waste. The case for thorium as a nuclear fuel. Historical background and characteristics of thorium. Thorium is a naturally occurring radioactive element that can be used as a nuclear fuel. Unlike uranium, which has been the primary fuel for nuclear reactors, thorium has several distinct advantages. Discovered in the early 19th century, thorium's potential as a nuclear fuel was recognized during the Manhattan Project, but it was largely overlooked in favor of uranium and plutonium. Advantages of thorium. Abundance. Thorium is about 3 to 4 times more abundant in the Earth's crust than uranium, making it a more sustainable long-term fuel source. Reduced waste. Thorium reactors produce less long-lived radioactive waste compared to uranium reactors. The waste products from thorium fission are generally shorter-lived and less radiotoxic. Proliferation resistance. Thorium-232, the naturally occurring isotope, is not directly usable for nuclear weapons production. This reduces the risks associated with nuclear proliferation. Developments in China. China has been at the forefront of developing advanced nuclear technologies, including sodium-cooled fast reactors and thorium-based reactors. The Chinese government has recognized the need to diversify its energy sources and reduce reliance on coal to combat air pollution and meet its carbon reduction commitments. Sodium-cooled fast reactor projects. China has been actively developing SFR technology, with notable projects such as the China Experimental Fast Reactor, CFR, and plans for larger commercial-scale reactors. These projects aim to enhance the efficiency and safety of nuclear power generation and provide a solution for nuclear waste management. Thorium research and development. China has also invested in thorium reactor research, particularly molten salt reactors, MSRs, that can efficiently use thorium as fuel. The Chinese Academy of Sciences has been leading efforts to develop thorium MSRs, with the goal of achieving a prototype reactor in the near future. Conclusion. As the global demand for electricity continues to rise, nuclear power remains a crucial component of a sustainable and reliable energy strategy. Sodium-cooled fast reactors, particularly those using thorium fuel, offer significant advantages in terms of efficiency, safety, and waste reduction. China's advancements in these technologies highlight the potential for a new era of nuclear power that can meet future energy needs while addressing environmental and safety concerns. Embracing these innovations globally could ensure a stable and clean energy future.